thank you for being here. I want to talk about all the things that I've seen and that Michael knows. And a quick question: who has heard the term generative AI at least 152 times today alone? Yeah, it's a part of our lives, whether you like it or not. I work in tech, so it's obviously a part of my life, especially my professional life. I work in tech and innovation because I'm passionate about it. I'm passionate about entrepreneurs. I'm passionate about what they do. I'm excited to help them get their tech off the ground. I'd love to know more about generative AI, so if I'm helping them, I know it's not to develop a Death Star somehow, which is a concern for a lot of us. So, do we know enough about it? What are the threats? What are the opportunities? More importantly, what are the conversations that we're not having is kind of what I'm interested in. And to help us explore that today, we're going to be joined by Michael Wu, an expert in the field. Michael has worked in the industry his whole life. He's familiar with every aspect of it. He can answer all sorts of questions. He's going to give us a quick run through of what it is, how it works, and what we can expect. Michael.
Dun, dun, dun. That's funny.
Well,
It's
my mic
something.
on? I don't think my mic is on yet. Is it on? Hello?
It seems to, yeah. Perfect.
Okay, so with that music, I have to say, this is the way.
Okay.
You guys seen The Mandalorian, right?
Yeah.
No? What happens when you say this is the way? You're supposed to repeat after me and say
This is the way.
right?
Yeah.
Okay, so let me
This
just,
is the way.
before I start, I have to say that this is a very difficult topic. This is a science talk, but I promise you, you'll understand it. This is a difficult topic because researchers around the world don't know everything about it. There's some phenomena or some properties that I do not know. Yet, I was, trying to make it accessible and interesting for all of you. I'm going to make this very interactive. So I'm going to ask for your participation. Okay? And I'm all good. So this is the way.
This is the way.
Okay, good.
New way.
All right. So I think today we don't need to introduce what ChatGPT is. Most of you probably have played with it, use it for productivity, or or just at least try to ask some question to this app. And you probably know that ChatGPT is something called a large language model, just from the news and media, right? But what does that mean? I mean, to understand ChatGPT and generative AI, we really need to understand what is a language model. Right? Now, to understand a language model, we have to step back a little bit and really understand what is a language. What is a language? We all know a language, right? So a language is really nothing more than the vocabulary and the grammar, right? Basically, the vocabulary and the syntax, right? So in machine learning, this is just a very particular sequence of words, arrangement of words. Right? It's not a random arrangement of words because you have to follow those arrangements, those specific sequence have to follow your syntax, your grammar, right, to make sense, right? So now, the language model is simply a probabilistic model that captures this sequential structure of the word tokens. All right? So that's about my team will talk to me about, right? But let me translate it to business, what that actually means, okay? So now, the question that I'm really trying to answer is really this, that given any sequence S, can you predict the next word W accurately? If you could do that, you know everything about the language. Okay? Say, you have to know how those words are arranged together. You have to know all the vocabulary. For example, if this is actually written in this way, probability of the word W given the sequence S. Okay? Now, if you don't know, this, whatever this is, right? The water is filled with ribulose bisphosphate carboxylase oxygenase. You know what that is? Everybody know what that is? That's an enzyme in chlorophyll that turns sunlight into ATP, the energy that we use. Okay? So if you don't know what that is, you wouldn't be able to figure how that works accurately, right? So to be able to predict that next word accurately, you have to know all the vocabulary, all the possible way that it's arranged, right? So you know everything about language, essentially. Okay? So, okay, so let's do a little exercise on do you know your English? You all are experts with English, right? So let's try your English skill, okay? So if I say the sky is, what's the next word?
Blue.
Is that only blue?
No, cloudy, up.
Gray? What else? High? What? So, okay, so notice that there's lots and lots of possible words, right? And that's why you need a probabilistic model, right? If there was only one word that follows the sky is, right, then you would not need a probabilistic model anymore, right? Now, so this probability is basically, written this way, right? Probability of the word given the sequence S, right? How do you calculate that probability? What should that probability be? If I have the sky is blue, right, basically it's you calculate it by finding the number of times you see the sky is blue divided by the number of times the sky is whatever, right? That's a probability of occurrence of the sky is blue, right? That's how you get that. So where do you get that from? Where do you get that probability from? You get that from any digitized human writing. Any, okay? So that literally means a web crawl of everything that's on the internet, and any digitized book, plus all the scientific journals which are already digitized, right? And Wikipedia as well, okay? So, this is a lot of text. Right? In fact, Wikipedia, may seem very, very big to you, but compared to the rest of it, it's actually very tiny. It only contribute about 3%. Okay, so this is the kind of data that we use to train ChatGPT. All right. So now, if you actually look at this probability distribution, what does it look like? Right? Basically, you know that when the word is blue, that's probably the most probable word. That's the highest probability. Right? If I sort this by a rank of the word token by their probability, you get like sky is blue, the sky is clear. It has just many, many possible words, right? Some of the other ones are less probable, right? And beyond certain, words, like probably a few hundred, right? There probably will be some words with essentially probability of 0. If you extend this all the way out to all the common English words, which is about, I would say, 30,000, around that range, right? I'm not a linguist, right? But it's about that size, right? So most of these tail probably have empirical probability of 0, right? And because we also include all the digitized books, scientific journals, and everything, right? So that entire lexicon of English language is probably a little bit over 1 million, all right? But most of those will have essentially a probability of 0, right? For example, you probably never see people say the sky is delicious, right? So that will have a probability of 0, right? Empirical probability of 0, okay? Now, what happens if I give you a little more context? If I say, the sun just set, the sky is, now what?
Yellow, golden, bright.
Bright, what?
Golden, yellow.
Golden, right? Pink, orange, right? Okay, good, right? So there's lots and lots of words, but you no longer see blue anymore, right? Because, so basically, what happens is when you actually give it a little more context, the sun is just set, the sky is blue, right? You go and calculate the probability, well, how many times the sun is set and the sky is whatever that word is, right? Divided by the sun just set, the sky is whatever, right? That's a number. That's a probability, right? But the interesting thing is, what used to be the high probability word get pushed down. They get pushed down, right? Because the sun, when the sun is set, right? It's just set, right? The sky would be blue, right? It wouldn't be dark, right? It could be cloudy, it could be dark, clear, right? Some of them will actually push all the way down to 0, right? Some of them not 0, right? But the interesting is a lot of other words get pushed up to the top as well, right? For example, like these blazing, golden, orange, pink, spectacular, all these words, beautiful words they use to describe a beautiful sunset. Okay? Now, what that means is that, basically this probability distribution actually gets sharper. They get concentrated. Okay? They get very concentrated. So now if you actually, give it even a little more context, for example, it's raining hard, the sun just set, the sky is, what would that word be? Gray, dark, cloudy, what else? Right? Lots of other words that describe it, but again, no longer, spectacular, golden, whatever, right? So now this probability distribution sharpens even more, right? So what that means is that to you, all of us, is that these probability distribution, they capture the word in a way that it stays in the topic really well. It stays within the topic. The more context you give it, it's able to stay within the topic very, very well. Okay? Okay, so now, these training data that was used to train ChatGPT, in total, is about 500 billion tokens. 500 billion words is a lot of words, right? But compared to infinity, it's nothing, right? Compared to infinity, is 500 billion is nothing, right? So basically, what we are actually observing here is what we call just the empirical probability distribution. Right? Empirically means like you observe directly from the data, right? Directly from the data. All right, now you probably have not seen this type of distribution before, but it's actually pretty complicated. It's high dimension. It's actually very hard to visualize. So I'm not going to show you what that is. So I'm going to show you a probability distribution that you all probably have seen sometime in your lifetime, and that's a Gaussian distribution. Right? So a Gaussian distribution looks something like that, right? And that's an empirical Gaussian distribution. You know that because it's a little jagged, right? It's not like perfect Gaussian shape, right? So what is the true Gaussian distribution look like?
Curve.
What? This is
It's
smooth
curve,
right?
yeah.
Okay? So it looks something like this, right? Okay? Now, the interesting thing is that, like, you see that in the empirical Gaussian distribution, there's some places that have zero probability, right? But does that mean the true Gaussian distribution has zero probability there? No, right? The true Gaussian probability have very small probability here and here on the tails, but they're not zero, okay? And that's why, when the fact that these are non-zero probability is actually critical. So keep that in mind for a second, right? So the fact that you have this empirical probability equals zero, it doesn't imply that the true Gaussian probability distribution should be zero. Okay? Right? Because empirical is based on a finite observation of the world that we live in. Okay? So now what does that mean? Now, just because you never see people say the sky is delicious, it doesn't mean that it's not possible. Right? It doesn't mean it's not allowed. Right? Doesn't mean it's not allowed, right? So now, if you actually use a prompt, right, to say that you write to ChatGPT saying like, I'm writing a storybook about a children's fantasy world where the clouds are made of cotton candy, right? And you probably would say the sky is delicious, right? Because when you actually, give it in the prompt, those words that are related to cotton candy, right, they get multiplied, right? And they, however small, they're not zero, but they can actually multiply by, a big number, they get actually pushed to the high probability region, okay? All right, so now, coming back to this is actually very important, okay? So, the fact that this true probability distribution is not zero, okay? The true probability, this probability of the word given any sequence is not zero, means that anything is possible under this distribution, right? This is actually how, generative AI is able to generate novel content, generate new content that never existed before. Just because you've never seen it doesn't mean you cannot generate it, right? That's the key, okay? That's actually why generative AI is able to generate new content. This is the way.
This is the way.
Okay? This is the way how generative AI generates new content that never existed before.
This is the new way.
This is the way. This is the new way, okay? All right, good. Excellent. All right, so now we know that we actually get this probability, this empirical probability distribution, which I denoted in blue color, from these training data, right? The problem is how do you get the real distribution? How do you get the real probability distribution of the words given any sequence? So this is where, now remember, this probability, this true distribution is a language model, right? If it's a big one, it's a large language model. Right? So that is, so how do you get that? How do you get that, right? This is actually where transformer comes to help, okay? They really are called transformer, seriously, okay? Now, transformer is really nothing more than a neural network architecture, okay? It is some complex neural network built in, the encoder and the decoder section, and at the end of this transformer, neural network architecture, there is an output probability. And that probability is precisely this probability of the word given any sequence. Any sequence. Okay? Alright? Okay? So now, what happens when you actually have the probability of something? You can sample it, right? Just as you would sample any random number from a Gaussian distribution, right? If you have a probability distribution, some probability distribution, some word probabilities are higher than other. When you draw randomly, some words are going to be more probable. You're going to see some, for example, the sky is right. You're going to draw more of the blue, right? From that probability distribution, right? So you can sample a word from this probability distribution, right? So what happens so you have a word now, right? What happens is that you actually can now concatenate this sequence with that word. So sky is blue, and they actually feed it back to this decoder of your transformer. Okay? Because now you have a new S, right? And now you actually have a new probability distribution for all the words again. Now you can sample the word again and repeat. That's why ChatGPT generates one word at a time. Okay? It's creating those sentences by generating one word at a time. Okay? Alright. And this part right here that I circled with the dotted line, this is GPT. This is the generative pre-trained platform. Okay? So now you know that generative pre-trained transformer is a large language model, but it really is nothing more than a random number generator. Right? It's a random number generator that's actually from a distribution of all words, right, given any sequence, right? And it's actually trained with all existing human writing with a transformer architecture. That's it, right? That's it. Now you can say, so this is random number generator. Is it really that simple, right? It really is that simple because all the complexity is actually get pushed into that distribution, right? If that distribution is not good, right, then when you actually sample words from randomly, you're going to get random stuff. You're not going to understand the word, what it's actually saying, right? But because that word probability distribution, the condition probability distribution of word given a sequence is so well characterized, right? You can actually randomly sample from it, and every word they actually sample from it will make sense, right? But it doesn't mean that you're going to get a sample every time, right? Like I said, it's a probabilistic model. And the sky could be blue, the sky could be gray, the sky could be dark, right? You're going to get different words, but you're going to get the more common words more frequently. Okay? All right? Okay. So that's that, right? But this actually doesn't sound very intelligent, does it? Right? Not at all, right? But you may actually say that, that's not quite fair, right? It's not quite fair because, this is just the GPT. Right? It's not really ChatGPT yet. Right? ChatGPT is the one that everybody knows, right? So how do we get from the base model of GPT to Chinese? It's actually almost there, really, because right now, if you just have this language model that's trained from all this training data right here, you get a language model, and now this language model basically can complete sentences for you, basically. It's gonna, if you give it any sequence, right, it's gonna complete for however long you want. Right? If you want to generate 350 words, just sample 350 words from that conditional distribution over and over again, right? If you want to generate 1,000 words, do it over 1,000 times, right? Okay? So the problem is that plausible continuation of text doesn't mean that you can actually answer questions, right? Or follow instructions or something, right? For example, you may actually ask a question, explain how cost-based pricing in B2B work. Everyone know what that is? Reading pricing or economics? Yeah. Good, excellent. Okay? So, excellent. State of California, we in good hands, right? So, yeah. So the large language model may actually come back with this, right? Explain how value-based pricing in B2C works. Right? And that's definitely a plausible word continuation, plausible continuation of the text. Right? Because, you can see this probably, in the training data somewhere, right? The training data probably has, maybe some econ exam or something, just list one question after another. Right? So this is definitely plausible, in fact, very plausible, right? So how do you, basically, we just have to tell this GPT model to ignore these type of response, right? And focus on what actually answers the question, actually addresses the question, right? So this is actually done through what we call supervised transfer learning to fine-tune the model to essentially follow instructions to provide answers, right? And now your ChatGPT, or not quite ChatGPT, your GPT model can basically follow instructions, right? You follow instructions really well. You ask anything, it's going to respond to you, right? But the thing that the people at OpenAI realize is that like knowing how to respond to questions doesn't mean you will always be a good kind of a conversation. Doesn't mean you provide a good conversation or open-ended dialogue, right? ChatGPT, as you know, is very expressive, right? It's very robust, and it actually talks to you like as a person, as a friend, right? That actually makes it very highly I would say people like to adopt it, right? Kind of almost like a kind of a person, right? Rather than as something like I would say Alexa or Siri or Google Assistant, right? Imagine how annoying you will be if Google Assistant or your Siri is half as robust as ChatGPT. You like bang your phone on the table and say, "Shut up!" Right? So how to actually train this GPT model to be to know what a good conversation or good dialogue is, right? So how do you do that, right? So the way to do that is like they use what we call reinforcement learning with human-in-the-loop ranking of the good dialogue. Right? So what we wanted to do is basically have GPT generate some dialogue, right? And then have essentially a human give it a score. Is it a good dialogue or is it a bad dialogue, right? Because only humans know what a good dialogue is, right? I mean, it's very hard you can't really describe to a machine, right? Score this thing high or score this thing low, because it's very hard to describe what a good dialogue is. You can't write it in code, right? But human knows it. Intuitively, we kind of know it. So if we kind of be in this loop and score it, right? Then it's done, right? The problem, so there's one problem, right? Scoring good dialogue is somewhat nebulous. And also, there's inconsistency among people too, right? We may all think that is a good dialogue, right? You may think that this conversation is good dialogue, but is it a 90% good? Or is it a 70% good? Or is it like 99% good, right? It's all good, but how good should it be, right? How do you calibrate across all these humans, right? So now, what ChatGPT, the OpenAI, what they did is that they actually used these humans to actually have GPT generate multiple responses. They essentially generate for, say here in 4 responses, right? And then they simply have humans rank them, right? Which response is better than the other, right? So that actually gives you a lot of training data, right? So we know that C is better than A, C is better than D, C is also better than B, A is better than D, A is better than B, and D is better than D, right? So however many you generate, we actually give you many, many pairs of training data to train this model to score a dialogue, to give it a score. How good of a open-ended dialogue is, right? So now, basically, you supervise train this reward function. This reward function is that you use all these humans just to essentially rank this. Essentially, these goes into training this another machine, right? So we call it a reward function, right? Essentially another AI, right? And its function is just tell you how good a dialogue is, right? And now you have one algorithm, so it's consistent, right? It's consistent. Now you actually train ChatGPT to have a real dialogue. Now, if you finish doing that, ChatGPT know how to have a dialogue, right? That's good, right? But the problem is that like ChatGPT still has no understanding of anything on the physical world. It doesn't understand physics, right? Doesn't know that if I drop this thing, it will fall, right? Doesn't know water work, right? When the empirical data has 0 probability, the true distribution that you sample from have non-zero probability. That's the key, right? So by construction, they will hallucinate. They will hallucinate, right? So this is an example, right? So this is I asked, tell me the name of every window product. Well, every window is a company that we recently acquired. The fair marketing platform, right? So it tells you a bunch of answers, and these first and second ones are indeed products from every window. Go to their website, you see the name to their various product. But then you generate a whole bunch of other ones too, right? So now these ones, actually I asked the CEO and the founder, right? Were these names ever used? They were never used throughout the entire operation of the company. But take a look at how good it's able to fabricate this data, right? It even knows, it has to kind of air something, kind of brand to it, right? It created a word. Air SEO is not a word, right? It knows how to create words like this. And it actually describe what it does very legitimately, right? Was there a question?
Yeah. Is the definition of a hallucination just that got the answer wrong, or what is?
It generated.
Or that it made it up?
You made it up.
Okay.
Yeah, okay, you made it up. Okay? All right. So hallucination will happen with generative AI. In fact, that is the fundamental property of any generative AI. They will hallucinate. Okay? Now the question is that a feature or a bug? Right? Is that a feature or a bug? Now, if you are in the design or creative industry, that's a wonderful feature, right? You want these things to generate things that don't exist before. Yeah, you want to generate art that never existed before. You want to generate design that never existed before. You want to generate music that never existed before. Right? Great feature. But what happens if you're actually trying to use it in a fact-based application? That's a bug, right? So that's a problem, right? So the question is, how do you actually overcome that problem? How do you overcome that problem? Okay. So what if these fact-based applications, it requires something called grounding. Okay. What does that mean? What does grounding mean? Okay. So now, remember that distribution that I showed you? The true Gaussian distribution looks like this, and the empirical Gaussian distribution looks like this, right? So grounding just means that when there's no data in the empirical distribution, don't make things up. Right? Don't make things up. All right? So one very simple way to do it is basically I could just multiply these two things together. Right? Basically, I could just set all the Gaussian distribution wherever it's non-zero, where the empirical distribution is zero, set it to zero. Right? But then you don't have a generative AI anymore, right? You don't have a generative AI anymore because now this generative AI can never generate anything that never existed before. You see the problem there? Right? Hallucination is a fundamental property of all generative AI. They will, and it's actually a feature, it's not a bug. Okay? Alright? So the problem is how do you actually overcome this problem? Right? So how do we do grounding? How do we do grounding? Okay, so one of the most used, I would say, technology in a fact-based application is information retrieval, for example, search. Right? If it exists, you should be able to find it because you crawl everywhere, right? You should be able to find it. Right? If you can't find it, it doesn't exist. Right? So information retrieval is actually how we traditionally deal with these fact-based applications, such as Google or any other enterprise search engine. Right? So now you can simply use this approach. So search first, right? Give the result to ChatGPT and have ChatGPT summarize it for you and give it back to you, right? But if you didn't find anything, just don't give it to ChatGPT. Just tell it there's nothing, right? If you give it to ChatGPT, it's going to make up stuff, right? So this is what we call retrieval augmented generation. It's using information retrieval to augment this generative AI, okay? So today, you see this, anybody use the new Bing search? Right? Anybody use Google search, a new one that actually have R and then infused in it, right? They're using this mechanism. They are using their plain old search engine to do the heavy lifting of searching the web and then giving the results to ChatGPT. And ChatGPT, since it can summarize stuff really well, a complete sentence really well, it just summarizes it for you. Okay? And that's why, like these, if you use Bing's search, you notice that they have these references, right? They tell you where it actually comes from, right? ChatGPT can do that. They can't. It's only because they do this step first, right? That's why they will give you the reference, right? So, by themselves, generative AI, you can't. You can't apply them directly to fact-based applications. But who says you have to use the technology by itself? You can hook it up in an interesting way like this, RAG, right? Then you could use it in the fact-based application as well. And you get all the benefits of all the non-fact-based application. All the creative and design professions are happy to, right? You don't have to use it alone, all right? Okay, so now let's go from the title. We're going to go a little bit beyond ChatGPT, right? ChatGPT is great, but that's just ChatGPT, right? It's just one thing. So I want you to focus a little bit on, I would say, there's actually a lot of these generic generative AI for different types of data, right? You have text data, which include text, code, and visual data, such as image, video, and audio, speech, and music as well, right? So if you just look at the text category, there's actually lots and lots of these large language models out there. In fact, like GPT is not even the first one, okay? The first one is actually BERT, that was actually created by Google, okay? Google invented BERT in 2017, okay? Because they actually invented the transformer architecture as well, okay? So now, if I can look at this, right? All of these models, every one of these actually have lots and lots of different applications coming out of this, right? You could do just help you with general writing. You can actually create text for sales, marketing, right? You could summarize notes, note taking for you, right? And even compare and contrast, right? So lots of applications. Many startups can be created just for any one of these applications, right? And if you actually look at the code, right? The code space, right? There's lots of different models as well, right? Basically, you could do like these code generation. You could generate code, right? So think about this. To a ChatGPT, code is just another language, right? Code is no different than Spanish or French to ChatGPT. It's just another language. It's just a language that we talk to machines, right? That's it, right? So what it does is that you simply take your English description of what you want to do and then translate it into actual code, right? So that's code generation. You can do it the other way around too. Once you have some code, you actually generate documentation for it, right? What this code should do, right? So there's actually lots and lots of visual and audio example as well. So lots more to come. But I want you to think about what's beyond that. What's beyond that? There are actually lots of, I would say, specialized generative AI. Right? So these are, for example, in the gaming world, right? They actually use this generative AI to generate 3D world, right? It's no longer generating just an image on a 2D canvas. It has to know a little bit about, how the 3D world works, right? For example, like this human motion diffusion model, it generates like realistic human motions, right? And it has to know that human arms cannot bend the other way, right? The joints cannot bend. I mean, we're not aliens, right? So it has to know something about how the human works, right? So that's kind of how it has to get these knowledge like beyond just, I would say, just the image that you generate, right? And there's actually, in the biotech space, you can actually generate like protein structures as well, right? From protein sequences and all that, right? So, and there's many more to come. I would say that, there's probably more in mechanical design, in the future you could design cars, the shape of cars, right? To generate 1,000 of them and actually, pick the one that actually perform the best in the simulation, actually build and test it, right? Change the way you work in the future, completely, okay? So, all right, lots more models to come, lots more use cases to come, and many more startups will be created, okay? All right, so one of the things that when you have a new hammer, right, you see everything as a nail, right? You want to think everything as a nail, right? So lots and lots of people, ever since ChatGPT was launched, right, there are lots of people coming to me and saying, what do you think about this use case? And very often it is that instance of, seeing everything as a nail, right? So some of these are good use cases, some of them are actually bad, some of them are, almost said, ugly. So we're going to go through some of these use cases, okay? Okay, so let's save the good one for later. Okay, let's take a look at some of the interesting ChatGPT use cases, but some of them do work, some of them don't work, and some of them are bad, and some of them do work, but probably not the best use of ChatGPT either. Because you just, you could use a hammer to, if you hit a log of wood big, enough time, you break it in half, right? You can cut the wood in half. Not the best use of your hammer, but it worked sometimes, right? So, okay, so one is like, can you discover market trends using ChatGPT? So what do you guys think of this? Come on, let's make this interactive. Would it work? Really? Okay? What happened if you ask me what happened this morning?
It's too complex.
Yeah, so market trends, right? So this probably will not work very well because if you ask it something, the market trend now, right? Probably it's going to say, oh, my training stopped in 2011, and I don't know anything beyond that, right? Okay? So not going to work. But hey, that doesn't mean we can't use ChatGPT with something else to tell you about what's happening now, right? That's what Bing search and Google is doing with that retrieval augmented generation, right? Okay, that means I have about 15 more minutes. Okay, so remember, how do you use these generative AI in a fact-based application? It's through this retrieval augmented generation. Okay, this is the way.
This is the way.
This is how you use generative AI in a fact-based application. It's through this retrieval augmented generation mechanism. Okay? It's highlighted. Make sure you remember. Okay? So, all right. So for this, then in this case, you're actually not using ChatGPT to discover the market trend anymore, right? The thing that actually discovers the market trend is your plain old search engine. Right? You're using ChatGPT as a summarizing engine to summarize it so that in a human readable language. That's it. Okay? So it could work. Not the best use case, probably, right? But it does work, I mean, you see Bing, if Microsoft and Google are doing it, can be, terrible, right? So now, how about this? Automated SEO keyword search, keyword research. Sorry, not keyword search, keyword research, right? Anybody do marketing here? If you do marketing, you know what that means, right? So can you use that for that?
Sorry, you asked
No.
about the web page or the SEO scoring.
Sure.
Looking for SEO recommendations based on your page.
Either way, right?
Either way?
Yeah.
Other way probably work, but then you would want to check that against a scoring mechanism.
Yeah, exactly. So that's the problem, right? So it's actually, you can't automate this completely, right? You have to, so ChatGPT can certainly give you a set of keywords to start with, right? For you to test, for you to experiment with, but it would have no idea how it performs, right? You have to test it to find out, right? It's not trained on any of the results of the search engine, right? So it wouldn't know how it performs. How would it know, right? So this probably doesn't work either, right? So another one, so this is actually a...
Sorry, could you tie that into like Ahrefs or SEMrush or something like that? When there's these tools that'll tell you what the ranks are, and they
but then you still have to do the research, right?
Okay.
So that's the thing, right? So the automated keyword research, you can use it to start it, right? You can tie it to some scoring mechanism to tell you how good they perform, right? But then, you can't automate it. Right? Not alone, not by itself, right? So can you use English to kind of describe kind of pricing methods, right? So people who do pricing, they basically do these pricing methods. They're essentially like Excel formula, right? So you can actually use English to describe as a formula. Can you actually translate it from English to this formula? Yeah, I think this one will work, but then it's like, I think it's probably not a very good use case either, because English is not a very precise language. Right? That's why formulas exist. Right? That's why mathematical formula and codes exist, because English is not actually a very precise language. I mean, imagine how would you describe a complex formula with like 7 levels of parentheses? Try to use English to describe that. You're going to give up in the middle where I might as well just type it in. If you know the formula, just type it in, right? It's probably easier for you to type it in. But I would say the other way around is probably a good use case. If you have a very complex formula, what the hell is this formula actually doing, right? Then it's actually a good use case to ask ChatGPT to explain to you what this formula is actually doing. Right? That's probably a good use case there. Right? So this one is actually interesting. So my cousin, she actually is a IT director in a big company. So she has to write performance reports for a lot of employees. And she now basically automates this in ChatGPT. So she just have to give the ChatGPT some context, right? This employee, has been with us however long, and she just create Excel sheet, with all the information, and then she just type in every quarter. She just write every few bullet point about how each employee areas improvement, and then you will generate the whole report, beautifully written. To send out, right? Works. Probably not a very scalable way, right? I mean, it's maybe this is a good startup idea for somebody to automate this and make it more scalable. Yes.
You mentioned about retrieval
Yeah.
being the way to do like truth and grounding.
Yes, that's one way to do truth and grounding.
I was going to say, do you consider the interpreter layer, like the code interpreter, or in this case,
Yeah, this is not using the plugin.
as a different form of grounding? And is that still retrieval, or do you subcategorize that?
Yeah, so that code interpreter is a plugin. Essentially, it's actually it's no longer using just the ChatGPT model anymore, right? It's using some other just like search engine, right? You can actually have in ChatGPT, you have plugin, right? You have like the Wolfram plugin, you have the search engine plugin, right? So now, ChatGPT actually allow you to kind of search the web, right? But it's actually not using its kind of ChatGPT model to do that. It's actually using to the plain old search engine to do that, and giving the result again, using this exactly the retrieval augmented generation mechanism. Okay. Yeah. Okay. So this works, but may not be the best use case either. How about this one? Explain complex data in chart. Right. So this one is actually again, English is not the best language to describe complex data. Right? That's why charts and graphs exist. That's why they exist in the first place, right? Imagine you're trying to describe this graph using this plain English, right? It's probably not going to work, right? But you can certainly use it to help you write a figure legend, right? To have focus on these points, right? These are the places that you should focus. So that's probably work. But so, like I said, some of these are. It's not that they just completely don't work, but may not be the best use case, right? Okay. So the last one, this one, enterprise knowledge base. So this one, a lot of companies actually using this. Basically, they are using that retrieval augmented generation mechanism that I told you before, but pointing to their enterprise knowledge base, right? Using their enterprise knowledge base as a source, right, to search against, right, using for the information retrieval, right? And then basically giving the results to ChatGPT and have it summarized. Right? So this one, a lot of companies that I talk to, they work somewhat okay. But a lot of them, there's also quite a them that doesn't work at all. And the one that doesn't work at all is that they basically have knowledge base that's poorly tagged and not well labeled. So these are obviously, it's again this issue of garbage in, garbage out. Okay, if you have not only just give you the document, but actually summarize it for you and actually tell you where to look in which paragraph, right, to answer your question. So it's very useful. Okay. But keep in mind, ChatGPT won't solve your bad data problem. It can't. Okay? Not yet, at least. Okay. So these are, I would say, the bad and ugly use cases. But what are some of the good use cases of generative data? Right? What are some of the good use cases? Right? So these are use cases that use the generative nature of this generative data. Right? So what is this generative nature of this generative data? It basically means that they're not prescriptable, and they cannot be pre-programmed, right? It has to be kind of created and generated at the moment when you actually use it, right? So there's lots of marketing use cases, right? So I don't think I need to say more. Right? You've seen people using it, generative AI to generate images, right? Personalized marketing, right? If it's so personalized, it's only specific to you, right? Probably that content is generated only for you. Probably will not be relevant to anybody else, right? So if it's generated only for you, then you probably use it only once, right? It's only good for you at this moment, at this time. Probably tomorrow it generates different content for you, right? So lots of those can be definitely used that way. But another one that's actually very interesting is like coding, right? Like I said, to ChatGPT, code is just another language. It's just another language, right? You can actually use it to write code for you. But there's a problem with this within the industry today. Anyone know what the problem is? Come on, you guys are not very interactive. This is supposed to be an interactive learning experience, right? It's copyright issue, okay? So things that are generated by generative AI are not copyright protected. Okay? So there's actually a case where the judge, basically ruled that so this woman, Chris Casanova, so she goes by Chris. So she actually used Midjourney, which is an image generative AI, to create a storybook that she's holding right now in the picture. Okay? So and she wanted to copyright that, and then basically the court said, you didn't create that, you You can't copyright that, right? You can copyright all the prompts that you use to create that storybook, but not the storybook itself, not the graphic that was generated by Midjourney. You did not create those things. Generative AI created those. You didn't. You can copyright all the prompts and the arrangement of this graphic. You can copyright those, but not the graphic itself. Okay? Direct outcomes of generative AI are not copyrightable, right? So, which company would use these generative AI to write code? I mean, people are saying that hey, English is going to be the most popular programming language in the future. It may be true, but who's going to use it if it's not going to be protected? Right? Okay, so there's actually lots of use cases where you have seen use it, because these are cases where things that you don't really care if it's been stolen or taken by other people, right? So what would some of those cases be? Right? So this is basically one example, right? So you can ask any natural language question against the database, and you can generate a SQL code for you, okay, to be executed against a known database schema. So to use this use case, basically you have to, what that's encoded in the prompt will have to be something about, some information about the database, right? So the database schema, the data dictionary, the column definition, all this information have to be somehow passed into ChatGPT as a prompt. Okay? And then you can actually ask any question, right? The thing that makes this a good use case that is not actually pre-programmable is that you can ask any question, right? You can't pre-program against that, right? If I were to kind of project it down to maybe 10 possible 10 most common questions that people ask about this database, then you could just program it. A lot easier that way, okay? It's actually a lot more energy efficient, a lot more cost efficient as well, right? If you do it that way, right? So the thing that makes this a good use case of generative AI is because you can ask any question. That makes it not pre-programmable, okay? So for example, you can say what is the total margin lift for my French customer last quarter, right? Then it's going to generate a SQL code, right? And you're going to actually execute that SQL code against the database, right? And then come back with some answers such as 5.78 million euro. All right? So now, something to consider, right? Using generative AI is not without risk. There's risk, okay? So what's the risk in this case, right? So maybe you should make sure that it's read-only, right? Maybe you don't want to say, hey, go in and update whatever data in there, right? So, and also respect all the access permission, right? Some people may not be allowed to see this answer, right? So you have to make sure those are still respected. And other thing that you should consider when you're building applications using generative AI is that you have to make sure that it's actually generate true value, actually generate value for people, and people will actually use it, right? So now, one thing to consider is if I generate this $5.7 million, how do you know it's right? How would you know it's right? How would you know? You ask this question against the database because you probably didn't know about it, right? So how do you know it's correct if it gives you this answer?
It's repeatable?
Well, I mean, right? How would you know? I mean, you have no way of knowing, right? So for you to check whether it's actually real, what would you do? You probably go and write the SQL against the database and check to see if it's actually real. If you're going to write the SQL to check it, then there's no value gain, right? Why not just write it in the first place, right? So the thing to realize is that human language is actually very imprecise, right? For example, this question in English, right, may seem very obvious to you, but to the machine it can actually be interpreted in many different ways. Right? I mean, say French customers, right? What do you mean by that? Do you mean only customer inside the country France, or do you mean any country that speaks French as a language, or do you mean so there's lots of ways, right? So you may actually sum up all the margin lift for all those things that you may not care about, right? So you have to worry about these kinds of things, right? So you have to step through this calculation, right? So keep in mind, without trust, there's no value. You have to trust it. It's like the early days of Excel, right? People writing Excel and basically calculate something, and what do? They use a calculator to check it, right? Same thing, right? You have to make sure that you have to have that trust has to be established, right? Otherwise, no point having Excel, right? Okay, so now, another thing that you mentioned before, right? So why not just have it generate any code, right? Why not generate just SQL? Why not just generate any code? generate any code, right? And this is actually some of the plugin that allow you to do this, right? The code interpreter is actually a plugin to ChatGPT that allows you to generate any code in Python, essentially Python. Okay? Now, this is very, very powerful because if you can translate English to code, right, or any human language, right? I mean, it doesn't have to be English; it could be French, Japanese, right? Any language you want. Translate that to code to the language the machine understands, right? You can pretty much do anything, right? Is there anything that you cannot program to tell a machine to do? There's very little thing that you cannot program to tell a machine to do, right? Lots of things can be, but you can pretty much do anything. Very powerful, right? Okay. So this is the way. So this is how you. This is the way.
Is the way.
Yeah, and this is the way how you should use generative AI. Is to use the generative nature of it, and don't use it to hit everything and treat everything like an app, right? Okay. So one very interesting question. I'm a scientist. Is that I'm actually quite curious. Why does it work so well? So this is actually some of the things that I would say a lot of people don't quite understand yet. Okay. So this is actually due to a phenomenon called high intradimensional correlation. So what does that mean? What does that actually mean? Now, this may not mean very much to you, but it's actually very apparent in visual data. Okay. So this is actually a picture of a place. Okay. Now I've simply masked out 99% of the pixels. Right? So you can't tell what it is. Okay. And I guarantee you, this is a place that you have never been to before because it doesn't exist. Okay. So, but if I slowly reveal these pixels more and more, can you start to see what it is in 97%?
Face.
It's a place. Okay.
Okay.
Right. What is
But
it?
it's
So can you see what it is?
face. Is it a
Not quite, right? How about 95%? Not quite. How about 90?
house, like a palace, maybe?
How about 80?
Oh, Colosseum.
Yeah, you can start to see it
Pizza.
about this, right? How about like 60? You can definitely see it now, right? You can definitely see it, right? So even though I mask out 60% of the pixel, you could basically fill in all those black pixels without too much problem, right? You have no problem doing that. I mean, you may not get exactly the pixel value right, but you probably will get one that's visually, right, by your eye, visually indistinguishable from what it really is. Okay? What about 30%? It'd be easy, right? So this is what it is. It's a fake generated image, right? That doesn't exist. So I guarantee that you have never been here because this place doesn't exist. Okay? So, right? So, like I said, if I ask you to fill in those black masked out pixels, right? And like 60%, right? You may not get every wave correctly, or every burr, or every cell hole correctly, but you will get one that will make perfect sense. Okay, all right. Okay, so we could do the same thing with music too. Okay, music. So anybody playing music here? Have anybody seen what music data look like? Okay, so these are spectrograms. This is what music data look like. If you actually play it, you will see what it looks like. So each one of those stripes is basically a note, a tune. Right, so this is spectrogram, right? Simple musical tune, such as Fairleys. Okay. So now let's try something more complicated. Right? How about this? Okay, so now you've seen what music data look like. Okay, let's try one more. Okay, so this is another type of audio data, not necessarily music.
And the only way to be truly satisfied is to do what you believe is great work. And the only way to do great work is to love what you do. If you haven't found it yet, keep looking and don't settle.
Okay, so speech data, right? Is that a great speech? Yeah. Yeah, great speech, right? So follow your passion, right? So I'm following my passion, so I'm okay. So now, let me do the same kind of experiment with you, okay? So this is actually some sound, some audio data, okay? I have masked out 80% of it, right? So can you fill in the rest of it? The 80% that I masked out right now? You can't, right? Just like the visual data that was masked out, right? You can't fill in when it's like 90% masked out or something, right? What about at 70%? Not quite, right? How about 50? Not quite? Kind of, right? You can kind of see the structure of what these sounds should look like, right? I mean, like I said, you may not get every one of these time point, this time sample correctly, right? But you probably get one that actually sounds auditorily indistinguishable from what it should be, okay? So these are auditory data, right? So visually, like I said, you don't have to get every pixel correctly, but you won't actually be able to visually tell the difference, right? Same thing. Auditorily, right? You may not get every tune, every precisely, right? But you will get one that actually makes perfect sense. It will be sound good to your ear, right? How about 30%? Can you fill in the rest of it? Can you kind of fill in the rest of it? You know, probably fill in something right here, right? So you can fill those in, right? So this is just that, okay? And that is
Gangnam Style.
See, this is what it is, right? And so, like I said, even if you don't get every time point correctly, you will get one that's auditorily probably indistinguishable to you. Right? Now, let's come back to the text domain. Okay? So ChatGPT actually wrote a poem for me. Okay? When I turned 50. I'm actually older than that. I'm actually a lot older than I look. So this is all right. So you try to fill in the blank. Right? Try to fill in the blank.